So how the most cities are in what way they are air polluted. So what made them air polluted? So which content is most high? So these are the things you can as well do that here. My case study is also that only. I hope you are seeing my screen and as well as my voice. Okay, audio is okay.
Yes, sir. We are seeing you are seeing the presentation, sir.
Yeah. So okay. So that is what actually you have. So this is actually a cluster analysis. So I'll just give the context of this here. So the term cluster analysis was first introduced by Tyron in 1939. So comparatively, this is a recent technique only, we can say that here. And then our own Indian, and then the first director and the planning commission chairman, Malanobis, PC Malanobis, has also contributed a lot of things. The distance, in terms of distance, that is called as Malanobis d square. That is also very much useful in the cluster analysis. So that he has found out. He's an Indian and he's a first director of Indian Statistical Institute, and then he is the planning commission commissioner, or the first person when Jawaharlal Nehru started the planning commission. He was the director for that particular planning commission situation. So then, it is nothing but what actually arranging the objects into groups in a natural and necessary skill that we all should share. So that is what actually you just see here. These are all the colors. You can as well do it with colors also. But this is the shape of the hat. So they are all into one particular group. So this is another shape where you have found into another group. This is another shape, they have fallen into another group. So this sort of a natural grouping is called as clustering. Like in zoology, if you just take it here, all flies into one this thing. All tailed animals into one particular group. All all tailed this thing are into one. Then ferocious animals into one particular group, and so different sort of this thing. So if you just take it botanically, botany wise, you want to see classify all plants into one particular group. All fruits into one group, all flowers into one group, and then no flowers, no fruits is into another group. So that sort of a thing can also be done. So this is the natural grouping. You cannot classify manually. So a technique by which you can as well do the arrangement of similarities among these groups here. So for that reason, we study the cluster analysis. Yeah, see here, this is actually a very good context with which you can as well do that here. So try placing the following faces into groups. What criteria do you apply? Size, hat, glasses, gender, hair color. Is there any different classification that makes as much sense as that here? So here, so this guy has wore a glass specs, right? So there are 3 people who are having specs. Then there are certain people having hat. Only one person is with hat, right? And then some persons are laughing, and these 2 are laughing. And this, whether I don't know that whether this guy is laughing or serious, right? So this guy is definitely laughing, and then his hairstyle is different. And one basic this thing is that here they are male and female. So this type of a classification is called as actually a natural group classification, and that I can as well go into this particular. Yeah. So this is the clustering which we study that here. So this could be what actually it could be a hierarchical or non-hierarchical. So if you just take it here, 1 to 12 faces are there. So their classification is as respect to the gender. So the gender is actually male, female, male, 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 male. So this is face number 1 is male, face 2 is female, and so on and so forth here. So if I just take it, this particular situation, glasses. So this is how it is. Mustache, this is the classification. Smile is this one, 5th face. I have just shown it here. He might be laughing or smiling or not smiling here, right? So then hat is no. Only one person is having a hat or a hat. So that's the reason this is the natural classification. So if you just take it in terms of many variables, so this sort of a classification is almost necessary. Like for example, you want to classify, so suppose if you are working on a big database and then you want to know that you are all graduates into one cluster and all postgraduates into another cluster, all less than graduates are into the one cluster in a particular company. So that can be so with respect to the with respect to their qualifications, you can as well classify. And another is that here you can as well classify through the gender. So another is that here as per their salary, you can as well do that here. What is the similarities among these guys whose salaries are drawn, right? So experience. So with experience also you can as well cluster it. So these various this thing you want to do it here, that can be done here. Right? So therefore, cluster analysis in most of the marketing situations. So this is actually a statistical technique, so which can be used to analyze the data on to have the natural groupings. So this is you can as well get the groups done through the further raw data. So then this is actually when I say that here 2 clusters, 3 clusters are there. Like for example, you have a whole data, and then as per their income levels, you want to divide them into lower income, middle income, and upper income. So now within within the lower income, they are similar. Within the middle income, it will be similar, and then higher they are similar. They are homogeneous. Between them, they are heterogeneous. So the distance from lower to middle is something, and from lower to higher, the distance is quite high. So this sort of a measurements or this sort of a patterns which you want to evaluate from the raw data, it is highly impossible. So hence you just do it. This sort of a distances. How do I get these distances? And then how much of distance is there from higher to lower, higher to medium, and then middle to lower. So this sort of a pairwise comparisons can also be evaluated by the clustering technique. So that is homogeneity, and if they are homogeneous within themselves, homogeneity will be there, and their distance will be very meager. If it is between groups, there will be a lot of difference. So that is what actually the context with which you evaluate the data. So that's what actually I said, dissimilar objects outside the cluster, particularly objects in other clusters. That is what actually we do. So this is, all of us can understand this in a market situation where you have, these are all what actually, there is one type of drinkers. So that is, there are, some people will drink for the status wise they'll do, and then individually they sit and then do. These are alcoholics, and then these are, for special appeal, people will drink here. So this is the cluster which you have. I want to get a cluster evaluated for this type of data. So these are, I say these are alcoholics. They sit only alone and then they drink here. So if I just say for special appeal, most people are drinking. That's what actually they are categorized A group, and then B group is actually Quantinus, right? So, and then this is for status, C group is drinking, and then individually sitting is D group. So this is how the distinction can be got under this particular context here, right? So, actually this is actually interdependence. There is a dependency. Initially you just take the raw data, and then there is a dependency within the raw data, and then you are classifying them into independent groups. And and then within the group you want to see the relationship. That's what actually I was telling. Distance will be, it could be a Euclidean distance or it could be a Malebranche distance. So within the group there could be similarities, but between the group there won't be any similarities. So therefore by using this cluster analysis, you can identify that here how many clusters are there, or you can as well fix the clusters you think, and then you can as well do that here. Both processes can be done under this particular context of this case here, right? So I mean that is what actually. So these are the various cluster analysis are being segmenting the market and determining target markets, product positioning, and new product development. So if a demand is there, then you just go for a new product demand and what will be the demand. So which sector of the people are interested in the new product development. So they do before launching, they do the survey and then formulate into a clusters of that particular data and see how best they will their product will be sold in the market, right? Then test markets also you can as well select by the clustering here. So these are the various aspects you can as well do that under the context of this here. So I mean, exactly that is what actually we wanted to have. The perception of the market surveys or the perception of a particular variables which you have collected, and then you want to know that here whether they are similar or dissimilar. So in what way they are dissimilar, in what way they are similar. So the distance, if the distances are not much, so they are similar. If the distances between the groups are it is high, so then it will be dissimilar. So that sort of a perceptions we are interested in. So this, how do you do this here? So the mathematics, most of the mathematics participants here, so you know that here this is actually a Euclid, I mean, this is the Euclidean distance used whenever you have a measurement values. Metric is what? Measurement, scale data. So this is how you just calculate the distance is square root of a square plus b square plus c square, right? So this is how you just do the I mean, computation of the data collected. Right. So this is another Minkowski metric distance. So this is the take the absolute value of xj minus xk values, and then this is the Euclidean distance, right? And then square root of that here. So you just get these distance. This is another metric. So this is the Minkowski metric, R metric, LP norm. So you just take it that way, and then you can do. So then you have Manhattan. So this is a very popular in most of the data sciences problems. People use this distance, Manhattan. So this is called as city block distance. So that is Manhattan distance. So distance is the sum of the differences between the coordinates. That's what actually I have. So I just get a, I've classified them into one particular cluster. So among these clusters, I see the distance of these distance of differences between the coordinates of that particular cluster, and then do that here. Suppose if I say within this thing, the coordinates are not much differed, so then they are homogeneous. Between the clusters, there could be a difference. So if higher the difference, both those two clusters turns out to be heterogeneous in nature. So that is what actually our interest is in this. So this is distance measure and metric. So this is called as the Malnobis, and this Malnobis, PC Malnobis has I mean found out this in 1936. Right? So I mean this is with which whenever Malnobis distance you want to be implemented on your data, so the data should be in multivariate nature. Then only you can as well do. So suppose if it is not multivariate nature, so then you can as well go for a Euclidean distance. So that is in both the cases, it calculates the correlations. So that is, I mean, necessarily the purpose of cluster analysis is that here you want to see the similarities. When I say similarities, the best measure is that actually correlation. So for a multivariate data, you just calculate the correlation matrix. And then say that here, if good correlations are there, so then they are similar. If they are not having any good correlation, they go into the other group. And that other group will be the dissimilar group as compared to this particular similar group. So that is the main context with which I want to study the data under the cluster analysis aspect. So then, so Malnobis distance in terms of a vector. So this is the how do you compute it? So this is mean vector, and this is your data, actual data, multivariate vector. And then this is how you just Malnobis distance is defined as x minus mu transpose into sigma inverse into x minus mu. X is your observation, multivariate observation. Mu is the vector of the first observations, x1 vectors. Then mu2 is x2 vectors. So that is also correlated value of mean vector. You just take it here, take the transpose. This is your correlation matrix, right? R1, 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 R12, R13, R14. So that is how the symmetric matrix, you just take it, take the inverse of that correlation matrix and multiply this and take the square root. That will be the Malebis distance which you calculate here. So the Malebis distance can also be calculated for vectors. So dissimilarity or similarities can be taken for vector measurements. Right? So normalized Euclidean distance is being calculated. Right? These are actually the normalization xi minus mu xi minus yi whole square by sigma I square. So this is for normalized vectors. We just take it here. So this is how you just calculate this. And then decide on the number of clusters which you want to take, and then take this map of these particular clusters, and then whether they are similar or not. So this is called as actually a dendrogram. So here all are just see here, they are being classified as what actually tailed animals and non-tailed animals. So that sort of a this thing. So this is what actually we construct. This is called as the dendrogram analysis, dendrogram visualization of the this thing. So here, if you just take it here, this red, this is one cluster. So in this cluster, these are the animals: tenrock, golden mole, etc. So these are the animals which are fallen into this particular. So this sort of a natural classification can be done. So then this is another one. So there are conservative vehicles, classy vehicles, practical affordable vehicles, and sporty vehicles. So they BMW goes under sporty vehicles, Porsche and Pontiac. This is actually the perceptual mapping, the data. As per the data and then features, they are being classified, and then they are being clustered into this. So within this particular, Ford is coming into one particular cluster, conservative model, Dodge and Plymouth. So they are becoming into conservative class of vehicles here, right? So here there are called as non-hierarchical. So this is one methodology which we do it here, also called as k-means clustering. And then hierarchical, and here it is, you have a single linkage and multiple linkage, etc. That is how you do the accumulative clustering, etc. You can as well do that here. Right? So I'll just go to a case study. I'll just go to a case study. Share this. Here. Share. So this is the data. So here, if you just see this data, this is actually a air pollution data. So if you just see this here, the first column is cities, cities, and then the second column is sulfur dioxide content of air in micrograms per cubic meter, and then average annual temperature is second column. Number manufacturing enterprise employing 20 or more workers. Then population size is as per 1970 census in thousands. Then air wind, so that is average wind speed in miles per hour. So that also pollutes the air. Then average perception, so precipitation, average annual precipitation in inches. Then average number of days per year with precipitation. So all these things are being taken into consideration, and you want to classify them, which cities are more polluted and not. So in terms of this thing which we want to do that here, I just go to this technique here. So there are, how many cities are there? There are 42 cities, I think. Yeah, 41 cities are there. So 41 cities are there. So I just classify that here. So I just go to, so I say classify, then I say hierarchical. K-means also I can do, but hierarchical I'll do. So I just take it city as my label class. So then I just take it these independent variables. So then I say statistics. So proximity matrix, continue, then plots, dendrogram. So vertical I can take it, horizontal also I can take it. I'll say horizontal, I'll just take it. Right. Method. So between group linkage and squared Euclidean distance, you can have anything: cosine, Pearson correlation, Chebyshev, Minkowski, customized, etc. So I say Euclidean, squared Euclidean. Okay, I'll just put it as it is. It really doesn't matter. Standardization, no, I don't want to do any standardization. Transform absolute values, change in sign, rescale. So these are all not necessary. So I'll just say okay. So then I'll say okay. So it is running. So this is how. Yeah, I got it. See here, so this is the case processing. There are 41 cities. This is the, I say these are the city one to city one. So these are the distances which are calculated, huge distances which I got it here. So then average linkage is being used. So between groups, so cluster one, so there are 10 and cluster two, there are 20, right? So they have fallen their coefficients, and then this is how this thing is being done. So how many clusters? So this is the this so how the visually it is seeing is the number of clusters is being seen here. So this is actually called as the dendrogram. You just see here this city 17 and city 11 are similar in polluting, and then city 35 and city 24 are polluting in the same. So but 27 to these 27 above this horizontal this thing, so there are many cities which are polluting equally. So they come into one particular cluster. So these many cities except this 24 and as well as 24 and this 35, right? But here 18 and 35, so they become one cluster here. So this is how this thing is being done here. So that is how you do the uh, clustering aspects under this particular context of data which you have. So this is actually by the uh, uh, I mean uh, hierarchical. So I can do the k-means cluster. So here you can as well say iterate and classify only. So I just take it this as all the variables into this thing here. So this is the city variable here. So then I say that here iterate. So I say maximum iterations are 10 iterations I have taken. You can increase if you want it, not necessary. Right? So an ANOVA table, a cluster information for each case is also there. It will take time, any options. So then I say that here, okay. So this is how you just got it. So these are the cluster values of two clusters. It is classified, and then their values are being taken. Initial cluster centers they are called as. So that is how you just got it here. So just here, city one is gone into second cluster. City 11 has gone into first cluster, right? Then so only two cities have fallen into similar in polluting, but the rest of the things are the same. That's what actually it amounts to, right? So here, as per the sulfur dioxide content, there is a difference in all the 41 cities, 100% significant. But average annual temperature seem to be the same in all the cities, 41 cities. Number of manufacturing enterprises are also polluting 100% significant in all the cities, 41 cities. So then population size, 1970 census, if population size is more in a particular city, population is high, then they are bound to pollute. That's what actually it says, the data. So then average wind speed in miles per hour, it is not. So wind speed pollution is not seen in any one of these cities. That's what actually it is saying. Then average annual precipitation, even precipitation also is not playing a role in polluting the air. So then average number of days per year with precipitation also not polluting. So that is the main cause of air pollution in these 41 cities seem to be sulfur dioxide content. Then number of manufacturing enterprises in the employees, where 20 more employees are being taken. So then population size. So these are the three variables which is really polluting the cities given there. So therefore, in cluster one, only two cities have fallen. So which cities are also case wise, we can as well, we have said that here. In cluster two, there are 39 cities which are similar in polluting. So that is what actually you can as well do in the in this particular methodology of big clusters which are being done through this particular procedure. So this is dendrogram, and then this is what actually the direct evaluation of the quick clusters which you want to study. So this is how the multivariate data analysis will be helpful, and this is not a cooked up aspects. So they are really scientific aspects, and then which you can as well rely on that. And then with my 35 to 35 to 37 years of experience, so I'm just doing it this year, and then no one has really questioned the analytics part of data which is being analyzed by me, and then they have got very good results. Most of the people who are really collected data, and then I have asked me to analyze this particular data. So that is the this thing with which you can as well dependable on the analysis through the statistical approaches. So thank you. Any questions? I'm here to clarify. Hassan.
Yes. Can you hear?
Yeah. Any clarifications? All the best for the exam, afternoon exam for all of you. So as Hassan says that here, don't get panicked, don't get stressed up, do it good.
Yeah.
Yes.
So see, we have this exam phobia, which
Yeah, yeah,
right from school they create.
yeah,
So a word of advice to everybody that just relax and take it.
yeah,
This test is not, we are not testing you, but testing ourselves to
yeah,
understand how much uh, we got, information across to you and how much you have understood.
yeah.
So I suggest relax and do it. And regarding this session, uh, clustering is a very important technique.
Yes,
In fact, the whole of multimedia which we have, just
yes,
a minute, echo which I will try to cut down.
yeah,
Yes, so very
yeah,
often we deal with data,
uh,
multivariate data, and we have to analyze this in many ways to see whether there are cross correlations, whether what is the relation, and whether also this clustering technique is very important when we want to see that there may be many variables which may be most important for a certain thing, and the others don't set a they are not much related.
yeah,
So with Professor Hargopal, we have done some work for astronomy.
yeah,
So when you have data with multiple variables, the metallicity of an object, the distance, the location, say for example, star clusters close to the
yeah,
galactic center, away from it, above the plane, below, and we look at the ages, we look at the chemical compositions, the enrichment, various things, and you want to see, yeah, the size of it, and you want to see what are the things which are close to each other. They close to the galactic this. So this kind of analysis helps you tremendously. Same
yes,
thing can be used in life science, where you have lot of parameters. A person may
yeah,
have diabetes, may have tuberculosis, may have maybe a smoker, a drinker, or addicted to caffeine. This, and you want to see what are the things which get related to a certain thing. So correlations, this clustering, and there are various techniques which can be used very beautifully
yeah.
to understand how
In
the whole
fact,
thing.
a lot of clustering is being used in a lot of financial data also nowadays. See, financial data is a lot of very varied nowadays. So where your, investments will be safe. So that sort of a thing you can as well also calculate. So the Standard and Poor and this CRISIL rating and all, they do this sort of multivariate analytics. So so you name it everywhere you can as well. This will be quite useful. So
Yeah.
at least you should
In
have.
fact, there's a lot of activity.
Yeah.
Now we are living in times of
Yeah.
data, and it's important that we can handle data well, and then that empowers
Yes.
you.
Yes.
See, data is being used for elections, winning elections. Data is being used for marketing. Data is used for in medical sciences, in chemistry, in mathematics, everything.
Yeah.
So we thank Professor Hargopal for taking so much of his time and
No, no,
helping
it's
us
all.
out with this. And I'm sure
My
he'll be
pleasure.
with us always. When you
Yeah,
need
it's my
him,
pleasure.
he's there.
Yeah, it's my pleasure. Yeah.
Yeah. So thank
Thank
you,
you. Yeah.
one and all. If there are any questions or things, please ask, or else we will now go back to our older link. Okay. Yeah, the link which we have been using all the time, we will go back to that, and then we may not have these interruptions which we had on this link.
Yeah.
So, any questions?
So, okay
Any
then,
chat?
Hassan.
Yeah,
Yeah,
thank you.
chat. Nothing is there. Yeah, thank you. Yeah.
Thanks a lot. Thank
Yeah,
you.
thanks a lot. Yeah. Right. Right.
We'll come back at 11:45. Bye bye.